In today's video, we'll be talking about actually two topics. The first topic is adding and subtracting polynomials, while the second will be multiplication. So let's start with section 5.2, adding and subtracting polynomials. And basically, the thing that you just need to remember with adding and subtracting polynomials is that you need to have like terms. Like terms meaning the variables have to be exactly the same as do your exponents. So if we look at example number 1, we see that all the terms are the same. They're all z to the 4th. So if that happens, then what you do is you just add or subtract the coefficients. So 2 plus 3 plus 1 minus 9 gives you negative 3, and then you just keep your term, z to the 4th. You don't add exponents, you don't add the z's, it just stays the same. The only thing you change are your coefficients. Again, what you want to do for example 2 is you're going to take a look at all 4 of them, and in this case they look similar. You have some x squares, some z's, but you also have some z squares and x cubed. Remember, they have to be exactly the same for you to combine these. So even though you have x squared and z, and this has x and z, you'll notice that the exponents don't match up. Therefore, they cannot be like terms. But you will notice that there are some like terms in this problem. The 3x squared z and the 8x squared z are like terms, so I can add those together. 11x squared z, again, only the coefficients. And you'll also notice that the negative 3x cubed z squared and the 12x cubed z squared are like terms, and I'll add those together. And I'll get 9x cubed z squared. And again, I cannot combine those because those exponents are not the same. And the last thing I want to kind of mention in this section is just to be aware of subtraction. With subtraction, especially if you have parentheses or it just says subtract the polynomials, you want to make sure that you do distribute that negative sign because it is subtracting the entire quantity. Probably the best way to do this is to right away distribute the negative sign to the polynomial that applies to, which would be this right here. Now this will be negative x cubed, but you'll notice the next one is 9x. There's no x squared, so I'm going to move it over here underneath the 8x. So it's minus 9x, and then since that's a minus 8, that will become positive by distributing. And then I'll go ahead and add the terms. 4x cubed, there's nothing there, so that will drop down. 4x squared minus x minus 4. So again, just make sure you remember to distribute. The second part of the video is multiplying polynomials. The first thing we're going to talk about is distributing with coefficients and variables in front of parentheses. Now, just like distributing with coefficients, I'll go ahead and do the 8 times the 9, which is 72. I cannot multiply the x with anything, so it's going to be x cubed. The y can be multiplied to the other y cubed. And remember, when you multiply with the same base, I add the exponent, so there's an imaginary 1 right there. So it's y to the 4th. And then the last thing left over is this k. So 72x cubed y to the 4th k. So it's just kind of distributing in and adding your exponents. If you look in example 2, we have two binomials. Now you may be familiar with the term FOIL, which is first, outer, inner, last, and it's very helpful when you're multiplying two binomials. You take the first terms, multiply them together, so I would get 2x to the 4th, again because we're adding those exponents. I would do the outer terms, which would be negative 3x squared y. I would do the inner terms, which is 2x squared y. And then finally the last, which is y times negative 3y, which is negative 3y squared. I would look to see if there's any like terms, which there are right here in the middle. And then I would just combine those and simplify. One thing I just want to make sure that you realize is that foiling is really just distributing. You're taking the first term and you're multiplying it to each term of the second. And then I take the next term and I do the same thing. FOIL you can only use with two binomials, so it's kind of important to know that's the distributive property in case you use more than two terms. The third example we have is 2k times the quantity k plus 1 squared. If you see k plus 1 squared, it's important to know that you cannot distribute to each term. So I can't say k squared plus 1 squared. That only applies with monomials and exponents. What this problem is really saying is 2k times the quantity k plus 1 times another quantity k plus 1. So again, do not distribute to each term the exponent, but instead rewrite the terms and then again use your foiling. So I'm going to do the 2k on the outside and I'm going to go ahead and foil the two binomials, k squared plus k plus 1. I'll simplify to get k squared plus 2k plus 1, and then I'll distribute the 2k to each one of those terms. I'll get 2k cubed plus 4k squared plus 2k. And our last example, we have a binomial times a trinomial. Again, I can only use the FOIL method if I have two binomials, so we're going to have to use the distributive property. I'm going to take the x and multiply it to all three of those terms. X cubed minus 8x squared plus 2x. And then I'm going to take the 3 and I'm going to do it the same thing to all three terms. And I'm going to line it up and get plus 3x squared minus 24x plus 6. I'll combine the terms, and this will be my final answer. X cubed minus 5x squared minus 22x plus 6.